Tropical Storm Floyd has dropped 3 to 6 inches of rain across the warning area. Heavy rain will continue for another 4 to 6 hours, which will push many small streams to near bank full or out of their banks. Be especially cautious at night when it is harder to recognize the danger of flooding.
In the past 5 years, Vermont has experienced 5 disastrous floods that have caused over $23 million in damage to public infrastructure, things as roads, bridges, and public buildings. We estimate that about 60% of that damage could have been avoided.
Right along the river corridors, large and small, that's where the best farmlands have always been found. That's where it's easiest to build the roads. Everyone from Native Americans to highway engineers always found it practical to travel alongside the edge of a stream. All of our development has tended to follow the water, and as a result, the impacts of mismanagement are felt very keenly. Avoidable damage is a whole category of problems that society picks up the cost for that didn't have to happen. After a big flow event, there's going to be some damage. There'll be flooding, there'll be some spot erosion, but there's a whole category of problems that can be avoided. This avoidable damage includes problems such as if you crop right up to the edge of a stream bank, you have nothing except corn roots holding the soil together, which it doesn't do very well. So when a big flow comes through, it cuts through that soil like butter, and a whole mass of sediment gets slugged downstream until it hits something that might cause it to slow down a little. Let's say a bridge that's a little bit undersized. Normally it gets by, but now this whole slug of sediment starts dropping off and eventually further clogs up one of the bays under the bridge. Before you know it, you have a major flood problem. People's houses are endangered, other erosion problems get triggered. These are avoidable damages.
There are two main factors that affect channel stability as far as the stream is concerned. That is the erodibility of the materials within which it's formed and the binding strength of the vegetation that's on the banks and in the floodplain zone. That binding strength comes from one of 3 different types of vegetation: grasses, shrubs, and trees. Grasses have a relatively small root zone depth, but they're very dense, and so they provide a lot of binding, but over a very small area. Bushes and shrubs have a greater root zone depth and have an intermediate density of roots, so they do provide effective binding of soils at a greater depth. Trees have the greatest root zone depth by far, but their root zone density isn't as high as that of shrubs or grasses. But all 3 are extremely important in stabilizing the banks and the floodplain area.
Plants have enormous ability to reinforce and stabilize stream banks, and they do it primarily in 2 ways. The first way is to strengthen and serve as literally a rugged skeleton to bind together otherwise sometimes weak soil and sediment materials. The second way is by covering the surface, either shielding the soil layer itself from the force of moving water, or else extending a dense tangle of branches out into the flowing water to slow it near the soil surface. In a stream with good riparian vegetation, you can see how these trees and shrubs really cause the water to slow locally. These plants are well adapted, they've got great roots, they're really strong. Some of them are even designed to let go of the top growth and hold on for dear life if the stresses get too high. So in the end, even though the water next door is cruising by really fast, moving a lot of sediment, moving unbelievable amounts with unbelievable force, eventually, when things calm down again, you can see these systems have survived intact. These trees are growing happily as ever. The shrub communities rebound nicely. The stream has kept its form, and this system is going to keep working for decades to come.
If we strip away that vegetation or reduce its effectiveness, then we remove each one of those factors. It doesn't slow down the flow anymore. It doesn't protect the bank from direct impingement from the flow, and it doesn't bind the soil particles together. So we lose on 3 accounts.
You can study streams from an aerial perspective, and in a healthy forest with an undisturbed watershed with good vegetation around the riverbanks, no alteration to the hydrologic inputs, that river stays really stable over time. Very few changes can be observed when you measure where the channel runs from year to year. On the other hand, when that channel comes near a highway where channels get moved around, banks get armored, stormwater inputs get elevated, when that water goes into agricultural areas where also sediment load, runoff volumes, and the vegetation on the bank, they all get altered. These are the areas where you start to see the channel respond by a lot of adjustment. That channel is constantly trying to find a new steady equilibrium state in response to those changes. And the change process the stream goes through is very uncomfortable to us. It's not good for habitat, it's not good for water quality, and it causes even more problems in terms of instability. When we look at orthophotographs, comparing them from year to year, we see the areas where the streams are stable are those areas where the riparian buffers are intact, and the areas where the most change happens are the areas where the stream corridor has not been respected.